Today we're going to be talking about perimeter and area. When we talk about perimeter, we're talking about the distance around the outside of an object. Now, when we talk about perimeter, the perimeter is generally measured in centimeters, meters, feet, and other examples could be kilometers or miles, ... That could go on for anyway. Now, when we're finding the perimeter of a shape, for example, a rectangle, triangle, or trapezoid, we simply add all the outside sides. Add all the outside lengths. So, for a circle, the perimeter is called the circumference. And is usually calculated by the following equations. C is equal to 2 pi r, or if you have the diameter, C is equal to pi times d, and remember that pi is equal to 3.14. And now on to area formulas. When we talk about the area is the space inside an object. And is typically measured in square units. So examples of these are centimeters squared, meters squared, feet squared, kilometers squared, miles squared. And this could go on for anything that has length. So now what we're going to take a look at is basically the ways to calculate areas for various regular shapes. We'll draw those shapes in a diagram on our chart, and then we'll just write down what our equation should look like. So I'm actually going to zoom in on the areas and actually take my time and make sure that all of the pictures are accurate. Now I want everybody to focus on their chart. Here we go. I'm just zooming mine in. And we're going to start filling in the diagram accordingly. I'll be changing my color to green, so it's a little easier for you to see. So when we're talking about a rectangle is basically a box with 90-degree angles. The opposite sides are the same for each. So if we have two parallel sides, and those parallel sides both have 90-degree angles with the other sides, what it's going to do is you're going to have a thing called a length and a width. So length goes left, right for us, and then width will go up, down. And when we calculate the area for this is just the length times the width. When we're talking about a square, it's just a special type of rectangle. That's where we have all sides being the same. And each side is at 90 degrees to each of the other sides. So this, we'll call this S. So for the area of the square, it's just A is equal to S squared. When we're talking about a triangle, triangles are calculated by using the length of the base and multiplying by the height. You can get a triangle that looks like this, which is just a simple right triangle. This is still your height, and this is still your base, isn't it? You could also get a triangle that looks like this, where I know that this original one was our base, and this could be the base for our other triangle. And this represents the height of my new triangle. So the area of any triangle is base times height divided by 2. When we're talking about a parallelogram is just something that looks like this. 2 parallel sides, but you notice the connecting lines are not at 90 degrees. This is the way we normally see them. The area for this, well, we need to have its height, and we need to have the parallelogram's base, just like before. But this time the area of the parallelogram is just base times height. What's really important for these special angles here is that when we're talking about a triangle and a parallelogram, the base and height must meet at 90. B and H must be at 90 degrees, or we can't calculate this stuff for the parallelogram or the triangle. So now we're going to focus on the trapezoid and the circle area. Let me just move this sheet up so we have everything where we need it. Now when we're calculating the area of a trapezoid, basically a trapezoid looks something like this. We've got 2 parallel lines, and those 2 parallel lines, they're not the same. They're not the same length, but they are connected by 2 lines that are not necessarily parallel. And when we want to find the area of this, so if I call this side A and the bottom one side B, the area is always going to be basically the height times A plus B in brackets divided by 2. Now, here we find that the height is just the distance between the parallel lines. And let's just put that there. The distance H equals distance between parallel lines. We need to make sure we understand that. And then finally, when we calculate the circle, the only thing we really need for a circle to calculate its area is its radius. And the area of any circle is pi r squared. Now, please remember that anytime you have a circle, circles can be represented as half circles, quarter circles, anything like that when we're doing these perimeter and area type calculations. So now we're going to talk about composite shapes. What you need to realize is that when we're talking about composite shapes, we're talking about shapes that are composed of several different portions of other shapes. So if you take a look at this problem here, we have a semicircle. We have a portion of a rectangle. And then we also have a portion of a rhombus possibly. And we would use that to calculate the area of all sides. So all three sides would come together. So now let's take a moment and split this problem up into three parts. We're going to take this one, and we know that this is going to be a trapezoid. So this is a trapezoid. This one here is going to be a rectangle. And then this is going to be half circle. Now this problem here has already been described to us as an area problem, so we're actually just calculating the area of the mini golf shown below. That mini golf area looks like a trapezoid, a rectangle, and a half circle. So what we're going to do is we're going to start by creating an equation of all three of these different types, and then we will start substituting the appropriate equations in. So the total area is going to be the trapezoid plus the rectangle plus 1/2 the area of a circle. So what we should do immediately is we should start by writing in all of the equations for all types. So for the trapezoid, h is equal to a plus b over 2. The area of the rectangle is length times width, and 1/2 of pi r squared for the circle. For the trapezoid, it's very important for you to recognize where the height is. If you take a look at this corner here that I'm showing you right here, this is at 90 degrees. So I would say that this portion, the 2.3, represents my height. So I'm going to do the appropriate substitution. 2.3 bracket 2.1 plus 1.2 and bracket divided by 2 plus now the area of the rectangle, which should be 4.6 times 2.5. Now, for the half circle, if I know the diameter is 2.5, I'm going to have to take this diameter and I'm going to have to split it in two. When I split that in two, half of 2.5 is going to be 1.25. And we're going to plug that into our equation for the circle. Now we must do the individual calculations. So I punch in my calculator and I find that my trapezoid calculation is going to be 3.795. We go and do the second calculation for the rectangle and we find that that is going to be 11.5. And finally, for the circle, we're going to find that it's approximately 2.45. Adding all three will give us a solution of approximately 17.7 meters squared. The only thing we should make sure of is that we show that there are some equal sides for the rectangle on our sheet. So just label that, and then for these, the trapezoid, we're going to show that there's two parallel sides. And I guess we could also put in that D is equal to 2.5. Therefore, R is equal to 2.5 over 2, which is equal to 1.25. We can put that down as some calculations on our sheet if we need to see it on the sheet. Now, finally, we'll do the total cost to cover the hole in the sod. If sod cost $2.87 per meter squared. what you're going to do is you're simply going to multiply the cost times the area. So let's do that right now. The cost is equal to 17.7 times 2.87 to get a total cost of $50.80. And we're done. Your homework will be a smartboard note that I'll provide on Schoology.